Strap yourselves in. We're going to Mars. Not just a few astronauts, thousands of people are going to colonize Mars, and I am telling you that they're going to do this soon. Some of you will end up working on projects on Mars, and I guarantee that some of your children will end up living there. That probably sounds preposterous, so I'm going to share with you how and when that will happen. Can we actually live there? Now, NASA may not be able to get us there until 2040, or we may get there a long time before NASA, but NASA has taken a huge responsibility in figuring out how we can live on Mars. Let's look at the problem this way. Here's what you need to live on Earth: food, water, shelter, and clothing. And here's what you need to live on Mars: all of the above plus oxygen. So let's look at the most important thing on this list first. Water is the basis of all life as we know it, and it's far too heavy for us to carry water from the Earth to Mars to live. So we have to find water if our life is going to succeed on Mars. And if you look at Mars, it looks really dry. It looks like the entire planet is a desert. But it turns out that it's not. The soil alone on Mars contains up to 60% water. And a number of orbiters that we still have flying around Mars have shown us, and by the way, that's a real photograph, that lots of craters on Mars have a sheet of water ice in them. It's not a bad place to start a colony. Now, here's a view of a little dig the Phoenix lander did in 2008, showing that just below the surface of the soil is ice. That white stuff is ice. In the second picture, which is 4 days later than the first picture, you can see that some of it is evaporating. Orbiters also tell us that there are huge amounts of underground water on Mars, as well as glaciers. In fact, if only the water ice at the poles on Mars melted, most of the planet would be under 30 feet of water. So there's plenty of water there, but most of it's ice, most of it's underground. It takes a lot of energy to get it and a lot of human labor. This is a device cooked up at the University of Washington back in 1998. It's basically a low-tech dehumidifier, and it turns out that Mars' atmosphere is often 100% humid. So this device can extract all the water that humans will need simply from the atmosphere on Mars. Next, we have to worry about what we will breathe. Frankly, I was really shocked to find out that NASA has this problem worked out. This is a scientist at MIT named Michael Hecht. And he's developed this machine, MOXIE. I love this thing. It's a reverse fuel cell, essentially, that sucks in the Martian atmosphere and pumps out oxygen. And you have to remember that CO2, carbon dioxide, which is 96% of Mars' atmosphere, CO2 is basically 78% oxygen. Now, the next big rover that NASA sends to Mars in 2020 is going to have one of these devices aboard, and it will be able to produce enough oxygen to keep one person alive indefinitely. But the secret to this, and that's just for testing, the secret to this is that this thing was designed from the get-go to be scalable by a factor of 100. Next, what will we eat? Well, we'll use hydroponics to grow food, but we're not going to be able to grow more than 15 to 20% of our food there, at least not until water is running on the surface of Mars and we actually have the probability and the capability of planting crops. In the meantime, most of our food will arrive from Earth and it will be dried. And then we need some shelter. At first, we can use inflatable pressurized buildings as well as the landers themselves. But this really only works during the daytime. There is too much solar radiation and too much radiation from cosmic rays. So we really have to go underground. Now, it turns out that the soil on Mars, by and large, is perfect for making bricks. And NASA has figured this one out too. They're going to throw some polymer plastic into the bricks, shove them in a microwave oven, and then you will be able to build buildings with really thick walls. Or we may choose to live underground in caves or in lava tubes, of which there are plenty. And finally, there's clothing. On Earth, we have miles of atmosphere piled up on us, which creates 15 pounds of pressure on our bodies at all times, and we're constantly pushing out against that. On Mars, there's hardly any atmospheric pressure. So Davin Newman, a scientist at MIT has created this sleek spacesuit. It will keep us together, block radiation, and keep us warm. So let's think about this for a minute. Food, shelter, clothing, water, oxygen. We can do this. We really can.